Hi everyone, my name is Alex Gutierrez and here I am with Diego Rodriguez. We are going to talk about, in this case, about an introduction to the peer-to-peer architectural approaches. The agenda for this time is, first of all, we're going to talk about some social media concepts. Then we're going to talk about what is a peer-to-peer. Then we're going to mention some of the most popular peer-to-peer systems. And then we're going to talk about how do we use peer-to-peer on knowledge management. Then we're going to talk about some social media architectural approaches using peer-to-peer. Then we're going to talk about what are our next steps for this investigation. So first of all, we're going to talk about what is Web 2.0, then what is user-generated content, then we're going to talk about what is social media, and then we're going to mention some of its types. So when we talk about Web 2.0, we are talking about a new way in which software developers and end users started to utilize the World Wide Web. That is, as a platform whereby content and applications are no longer created and published by individuals, but instead are continuously modified by all users in a participatory and collaborative fashion. This involves the usage of RSS and Atom, which are used for web feeds, or also Flash and HTML5 for animations and interaction with the UI, and also Ajax for web content updates. Now, what is user-generated content? Here we have two definitions. The first of them says that user-generated content is the sum of all ways in which people make use of a social media. The other one says that that user-generated content is the various forms of media content that are publicly available and created by end users. Now, this needs to fulfill three basic requirements. The first of them is that user-generated content must be published either on a publicly accessible website or on a social networking site accessible to a selected group of people. This doesn't involve mails or instant messages. The other requirement is that it must show a certain amount of creative effort. Let's say that this information must not be repeated. And the last one of the requirements is that it must have been recreated outside of professional routines or practices. For example, this must be not commercial, not in a market context, for example. Now, what is social media? This is the most important of the concepts in this case. Social media is a group of internet-based applications that build on the ideological and technological foundations of Web 2.0 and that allow the creation and exchange of user-generated. There are many types of social media. The first of them are collaborative projects, which are projects that enable the joint and simultaneous creation of content by many end users. For example, wikis, social bookmarking applications. The other ones are the blogs. Blogs are websites that usually display daily stamped entries in reverse chronological order. The other ones are content communities like YouTube or Flickr, which share media content between users. Then the social networking sites as Twitter or Facebook, which are the most known, I think, which are applications that enable users to connect by creating personal information profiles, inviting friends and colleagues to have access to those profiles, and sending emails and instant messages between each other. The last one is are the virtual worlds, which are platforms that replicate a three-dimensional environment in which users can appear in the form of personalized avatars and interact with each other as they would in real life. There are two types of virtual worlds. The first one are the virtual game worlds, and the second ones are the virtual social worlds. The first one requires their users to behave according to some strict rules in the context of a massively multiplayer online role-playing game, which is a MMORPG. The best example for this is World of Warcraft, for example. Then the virtual social worlds allows the inhabitants to choose their behavior more freely and essentially live a virtual life similar to the real life, like on Second Life. Now, how can we categorize these social media types? There are basically two criteria. The first one is the social presence and the media richness theory. Social presence is defined as the acoustic, visual, and physical contact that can be achieved to communicate between two partners. And the media richness theory is the assumption that the goal of any communication is the resolution of ambiguity and the reduction of uncertainty. It states that media differ in the degree of richness they possess. Now, the other criteria is the self-presentation and the self-disclosure. Self-presentation is defined as any type of social interaction between people that have the desire to control the impressions other people form of them. And the self-disclosure says that the conscious or unconscious revelation of personal information must be consistent with the image one would like to give. So basically, in this chart we can see that blogs, for example, have the lowest social presence and media richness, but have also one of the highest self-presentation and self-disclosure. And on the other side, it are, for example, virtual game worlds, which have the highest um, social presence and media richness, but have one of the lowest social representation and self-disclosure. So now, what is peer-to-peer? A peer-to-peer computer network refers to any network that does not have fixed clients and servers. In a peer-to-peer network, every peer node will function as both clients and servers to the other nodes on the network. Peer-to-peer networks form a decentralized and self-organizing overlay network on top of the internet, on which peers are interconnected and directly interact with each other to share resources, without central services. Now, here we can see a graphic of what will be a peer-to-peer network. As you can see, it looks like a non-directed and cyclical graph. Every computer can share information with each other, and there is not a center between them.
Now we are going to talk about popular peer-to-peer systems. We have identified five, which are Napster, Gnutella, Freenet, Maves, and Skype. Napster is a peer-to-peer system that allows anyone to publish a list of music files on their computers that they are willing to share on the Napster server. The server matches up requests for files with a list of providers, but the files themselves are transferred directly from personal computer to personal computer. These files do not pass via the Napster server as they would do in the client-server model. This is possible because Napster used peer-to-peer algorithm to work around the structure of the internet and allows computers that do not have domain names to locate each other and exchange specific files. Also, Napster uses a client-server approach for some tasks and peer-to-peer approach for others. This is known as a hybrid peer-to-peer approach. In the picture, we can see how Napster works. First, a computer starts a search and the central index server matches up the request with some computer. Then, the computer with the required files sends it directly to the computer that was looking for it. The next peer-to-peer system is Gnutella. This system broadcasts messages to all the peers in the path of the query, but this approach has a performance problem. It generates huge network traffic, slow response, and congestion. This traffic is mainly due to messages for establishing initial connection and for queries. Also, Gnutella does not exploit the fact that people with similar interests are likely to store files that would be useful for other people sharing those interests. Here we can see how Gnutella works. The query goes through all the network, and when it finally finds a computer with that file, it returns a message through all the computers between the first and the last computer. This causes a huge traffic network. The next peer-to-peer system is Freenet. This is a free software which lets you anonymously share files, browse and publish free sites, websites accessible only through Freenet, and chat on forums without fear of censorship. This system has a pure peer-to-peer approach and looks out for popular files and ensures that a number of copies exist in various places and move the information close to the place where it is on demand. About this last point, it's important to say that this helps to ensure that computers containing the information are not overloaded with requests. Also, this enables access to files even if the originating computer is offline. The next system is Maze. This is a file sharing system that has a collection of index servers that store information about all files available on peer nodes, regardless of whether a particular node is online at the moment. The client then contacts multiple replicas to perform a swarm download, where fragments of the file are downloaded simultaneously from different sources. Maze uses an incentive model, this is giving points to users for seeding in order to deal with free riders. Free riders are users who log on, download their desired files, and quickly log off to conserve their resources. This graphic explains how Maze works. First, the client uploads file metadata to a Maze server. Second, metadata is replicated to a subset of index servers where they are indexed. Third, clients send queries to Maze search servers, and finally, queries are resolved by index servers. The next peer-to-peer system is BitTorrent. It works by breaking files up into small pieces. The file is downloaded piece by piece from one or many different sources. The name BitTorrent is also used to describe the official BitTorrent client. With BitTorrent you make, distribute and get files. To make and share a file of group of files through BitTorrent, you first make it into a torrent, which is a small file which contains information about the files and about the computer that coordinates the file distribution. In this picture we can see that the client coordinates the pieces of the file that are needed to get the original file. Also, all the computers with the BitTorrent client receive and sends multiple pieces at the same time. Finally, the last peer-to-peer system is Skype. It is a VoIP service. It uses three main entities in a Skype network: supernodes, ordinary nodes, and the logon server. Besides Skype login server, Skype has no central server. A Skype node is simply a computer running the Skype application, also sometimes called a Skype client. A supernode is also a simple computer running the Skype application, but the Skype application has selected it to take on some of the administrative and coordinating activities of its peer-to-peer network.
We are now going to talk about some of the applications of peer-to-peer on knowledge management. The first of this is the architecture that Bonifacio says in his paper. Here we can define some of his principles. The first one is the principle of autonomy, the principle of coordination. Then we're going to talk about centralized knowledge management architectures versus the distributed ones. And then we're going to talk about distributed knowledge management. And at last, we're going to talk about his peer-to-peer architecture. Bonifacio defines something known as the principle of autonomy. Principle of autonomy says that each community has a high degree of autonomy to manage its local knowledge. Autonomy can be allowed at different levels, and he says that we are mainly interested in what we call semantic autonomy, namely the possibility of choosing the most appropriate conceptualizations of what is locally known. The second principle he states is the principle of coordination. Principle of coordination states that each community exchanges knowledge with other units not by imposing the adoption of a single, common interpretative schema, but by adopting a mechanism of meaning translation across different interpretative contexts, called semantic interoperation. Now let's talk about the centralized knowledge management architecture versus the distributed knowledge management architectures. The centralized ones views organizational cognition as a convergent process that collects peripheral raw knowledge from various sources and codifies it into a central repository. On the other hand, the distributed ones represent organizational cognition as a distributed process that balances the autonomous knowledge management of individuals and groups, and the coordination needed in order to exchange knowledge across different autonomous entities. In the first case, technology is required to enable central control, standardization, high capacity, and robustness. In the second one, it should enable distributed control, differentiation, customization, and redundancy. Here we have the main characteristics of Bonifacio's architecture. First of all, Bonifacio uses something called knowledge nodes, which is described as the ratification of organizational units, either formal or informal, which exhibit some degree of semantic autonomy. Then there is the concept of meaning negotiation, which is the process of meaning assessment and comparison across different categorization schemas. And later, here is the concept of cooperation. Cooperation says that the nodes must have the ability to federate. This means that the nodes should be able to spontaneously federate, creating groupings and communities of nodes that display a common interest. They should also have the ability to discover, which means that they should be able to find each other, having the opportunity to discover who is available, what type of services are accessible, and what kind of conditions are necessary to establish communication. Knowledge nodes must have also the ability to propagate. This means that a knowledge node that looks for information should be able not to directly interact with all the knowledge nodes in order to understand who has the required knowledge. Rather, it should be able to trust that a limited number of interactions with neighbors give sufficient chances to find the right counterpart. And the last of them says that knowledge nodes must learn. This means that they must maintain semantic relations with other knowledge nodes. Here we can see what is the Bonifacius architecture. We can see that here there are two roles. The first one is the seeker, which is the role that is going to send the query, and then there are the providers, which are going to process these queries. As you can see, the seeker sends the query to the providers, and the providers process these queries, but they can also propagate the query to another provider, and then they can communicate between them. And finally, one of those providers is going to send the response to the seeker. Now we are going to talk about the Bertolini's knowledge management peer-to-peer architecture. First of all, he uses the Tropos methodology. Then we are going to talk about also what is the JHTA framework that he uses in his architecture. And finally, we're going to talk about his architecture as it is. Well, so what is the Tropos methodology? Tropos methodology adopts an agent-oriented approach to software development. It performs conceptual modeling using a visual language, as you can see in the graphic below, that provides intentional and social concepts such as actor, goal, belief, plan, and dependency. The graphic below shows GNutella, but modeled as a Tropos methodology graphic. Here you can see that there is a servant that is communicating to another servant, but he is communicating by providing services, by discovering other servants, or by searching other services also. In this approach, Bertolini uses the JHTA framework, which is a set of open generalized peer-to-peer protocols that allow devices to communicate and collaborate through a connecting network. Basically, in his architecture, he defines three concepts, which are peer, peer group, and service. Peer is any device that runs some or all the project JHTA protocols, and a peer group is a group of peers that have agreed upon a certain set of rules to publish, share, and access data and applications. Each group can establish its own membership policy. Here we can see a graphic describing how peers and peer groups interact using the Tropos methodology. As you can see, peers can discover and create a group, which both of them means that they can find a group. They can also join a new group, and by finding a group or joining it, they can join the right group, which is one of the main concerns here. And also they can handle services requests and use services. Both of the handling and the usage of services means that they can implement group sharing services. And by implementing the group sharing services and joining the right group, they can access a shared services. Also, peer groups, when a peer joins a peer group, it's being a member of it, so it has to implement a membership policy. And they can also publish and discover inside this group, which means that they can manage the communication inside it. Now here we can see another graphic which describes how a peer group works, or basically the ideas, the concepts that are involved here. Basically, a peer group has the ability of discovery and publishing, which means it can be dynamic. It can also implement an access protocol, and the membership policy, which is involved in the security. And they can also, well, they have also a communication infrastructure, and they have to implement the monitoring, which means they are decentralized. So now let's talk about the Bertolini et al. Peer-to-peer knowledge management architecture. Basically, he defines two concepts, which is the first one is the individuals, which is defined as someone who can access other resources or can let others access its own resources. Individuals have constraints and preferences. Also, there is the concept of virtual peer-to-peer community, which lets users cooperate for sharing a specific type of resource or service. Peers and communities can use the shared resources in their own way. Now here we can see a scenario with the Tropa methodology that wants to explain the Bertolini et al. Architecture. We can see that there are many peer groups, which are, for example, the health insurance group, the accounting office, and you can see that they share services. But as you can see here, an accounting office, for example, can use the information of a bill to compute the bill, but they can also send that information to the health insurance so they can know the payment. As you can see here, the services can be implemented in different ways for each group, and they can share that information between them. Now let's talk about the social media architectural approaches. The first one of them is the Trump et al. Architectural approach for social media. Here we're going to talk about what is a distributed social network, then we're going to define some concepts, and then we're going to talk about the architecture for social media. Well, let's talk about the distributed social network principles. The first one is the linked data principle, which says that the main protocol for data publishing, retrieval, and integration is based on the linked data principles. The second principle says that, well, it's about service decoupling. It involves the decoupling of user data from services as well as applications. This helps users of the DSSN, which is the distributed social network, to distinguish between their own data, which they share with and license to other people and services, and foreign data, which they create by using these services and which they do not own. The last one is the protocol minimalism, which says that the main task for social networking protocols is to communicate RDF triples between DSSN nodes, not to enforce a specific workflow nor an exact interpretation of the data. This is used just to communicate. So, well, in this architecture we have to know some concepts, basic concepts. The first one is the Web ID concept, which is a dereferenceable RDF document describing its owner. Then we have the concept of friend of a friend, well, FOAF, which is the acronym of friend of a friend, as I said, and it's a machine-readable ontology describing persons. The last one is the RDF, which is an acronym for Resource Description Framework, and it's a family of World Wide Web Consortium specifications, originally designed as a metadata data model. Well, in this architecture there is also a concept, and it is implemented, which is called the semantic pingback. It is used to facilitate the first contact between two web IDs and establish a new connection, which is known as friending. It is used to ping the owner of different social networks artifacts if there are activities related to these artifacts, like commenting on a blog post, tagging an image, sharing a website from the owner, or other things. So, well, let's explain here the graphic. First of all, we can see, well, in the number one, a linking resource links to another web resource, here called linked resource. Next, on the second step, the pingback client is either integrated into the data content management system or realized as separate services, which observes changes of the web resource. Third, once the establishing of a link has been noted, the pingback client tries to auto-discover a pingback server from the linked resource. Fourth, if the auto-discovery has been successful, the respective pingback server is used for a ping. Fifth, in order to verify the retrieved request and to obtain information about the type to the link in the semantic case, the pingback server fetches the linked resource. And last, subsequently, the pingback server can perform a number of actions, such as updating the linked resource or notifying the publisher of the linked resource, via email, for example. Another thing that we use in this architecture is something called pub sub hub bob. I think if this is pronounced well, which is an open protocol for a distributed, published, subscribed communication on the internet. The main purpose is to provide near-instant notifications of change updates, which would improve on the typical situation where a client periodically polls the feed server at some arbitrary interval. The other concept that we must know for this architecture is what is called Sparkle. Sparkle is an RDF query language that is a query language for databases, able to retrieve and manipulate data stored in resource description framework format. Well, so here we have a graphic that summarizes the Trumpetal social media architecture. First of all, we can see that there are three basic layers. The first one is the data layer, then we have the service layer, and finally the application layer. First of all, you can see that resources announce services and feeds via links or header fields. Then feeds announce services in a particular push service. Then applications initiate a ping request to spin the linked data network. Then applications subscribe to feeds on push services and receive instant notifications on updates. Then update services are able to modify resources and feeds on demand of an application. And then we can see that personal and global services can index resources and are used by applications. Access to resources and services can be delegated to applications by a web ID. The application can act in the name of the web ID owner. The majority of all access operations is executed through a standard web request. The next social media architecture approach that we are going to talk about is the Calaphonos. Here we're going to talk about the tools that he uses and the architecture itself. For this architectural approach, Calaphonos uses the managed internet architecture and he builds his own architecture upon it. This architecture, the UIA, provides a strong permanent location independent device identifiers and allows users to securely bind personal names to devices. He also uses the JSTA that we mentioned before. Now, what he built was called MyNet. MyNet is a peer-to-peer social media system that has support for mobile devices. It is built using UIA and JSTA, as I said before, and allows users to define rules for sharing and accessing files. It uses wizards for easy configuration. Now let's talk about some of the definitions that he uses inside his architecture. The first one is the endpoint identifier, which is each device creates a uniquely public-private keeper and hashes the public key to create an endpoint identifier, which acts as the permanent device address. Then we have what is called the personal device clusters. After a device is imprinted, after it gets its own ID, it can be merged with other devices to create a personal device cluster. Merging requires own authentication on both sides and is reversible. Also, we have the concept of passlet. This is one of the most important ones. Passlets define user-level permissions, for example, permissions that are meaningful to humans. And then we have the concept of cumulative passlets, which express the overall cumulative effects of all individual passlets granted or received by the user. So, Calaphonos uses many UI wizards. The first one is the MyNet Manager, which uses API calls from the PDC store and SRD models to retrieve discovery records. Then we have the MyNet Viewer, which is the front-end UI application. Then we have the MyNet Passlet Manager, which uses API calls from the PDC store, MyNet Sec, and control modules to create, edit, browse, and revoke passlets, which, as I said before, is used to grant permissions. We have also the Introduction Manager, which uses the API calls from the out-of-band introductions module for the process of adding new devices and social contacts to the network. Here we can see the graphic of the Calaphonos architecture for social media. As we can see, everything is built upon the UIA framework and JSTA protocols. Well, first of all, we can see that there is a PDC store, which stores the information for different services and devices that the user uses, but also it has the received and sent passlets. Then we have the MyNetSec modules, which manages the security of the framework. Also, finally, we have on the top part the different front-end applications and wizards that the user uses, like the Passlet Manager and MyNet Imprinting, for example.
Next, we are going to talk about Seung et al. He doesn't propose a peer-to-peer system, but he proposes a distributed architecture using cloud computing. Seung et al. presents the PRPL, which is a distributed architecture using cloud computing. It is based on three principles. It is decentralized, it has open AP, and it's trustworthy. It's important to explain some terms we found on the paper. Personal Cloud Butler organizes our data and shares them with our friends based on our private preferences on access control. Federated Safe Haven for personal data. Safe haven for all our personal data, from emails to credit card purchases. To make advantage of freely available data storage on the web, the butler lets the user store part of their data, possibly encrypted with different storage vendors. Provides a unified index of the data to facilitate browsing and searching, and hands out certificates that enable our devices and friends to retrieve the data directly from storage. Social multi-database. The butler from a network of a decentralized social multi-database, each butler in a separate administrative domain. A query from a friend may trigger a cascade of queries through our friend's butlers. Data represented using RDF and standard ontologies whenever they are available. Socialite language is based on datalog and declarative database language that supports function composition and recursion. Access control rules that are composed with external queries to create an efficient query against the database. Use a rewrite system that automatically enforces access control without relying on the cooperation of third-party software vendors. Decentralized ID and server management establishes personas by using OpenID, a decentralized ID management system. OpenID provider supports the lookup of a designated butler with an OpenID. Session tickets, used for single sign-on between butlers and other butlers and their respective third-party applications. Data stewards, used to manage blob objects that are stored remotely. Uses their indexes. In this final image, we can see all the architecture of PRPL, which is based on cloud computing. Now we are going to talk about social-based peer-to-peer systems. The first one is Dribbler, and it has 5 components in its architecture. The first one is social groups that consist on de-anonymized peers and facilitate social group formation. The de-anonymization is achieved by having every user choose a nickname. Mega cache, the constant information that needs to be saved in order to improve the performance, consists of information on social relations, address levels, peer uptimes, taste similarities, and other information. Taste body-based content discovery. The bodycast algorithm uses an epidemic protocol to change preference lists using the overlay swarm, and which can efficiently discover an user's taste buddies. User interface is split into 5 components: map, downloads, my friend, files I like, and taste buddies. Bootstrapping. Finding other peers in a peer-to-peer system after software installation is called bootstrapping. Now we are going to talk about how social components can be included into existing peer-to-peer systems. For example, in order to improve Unitella, we can include the next concepts. Semantic social routing approach, which says that we can have a list of peers that share the same interests with us and classify them in categories. Strange of relationships. Each category is and its peers are category independent. Semantic routing. The best solution is to forward the query to a small number of computers. Discovering new friends. For downloading a file, the worst scenario would be that the peer is outside of any of our categories. The benefit of all these concepts are that the queries will travel less and success is more likely to be achieved with a smaller number of hops. As a standard rules, some social norms must be defined. According to Yu Shang and Michaela van der Schaar, these social norms should include a method for providing incentive based on reciprocity, where the peer's behavior is rewarded or punished in future interaction with other peers. Also, these norms should consider the asymmetry of interest among peers, service errors, multiple connections, simple protocol designs, and altruistic peers and malicious peers. Finally, the next steps we have identified are research about existing peer-to-peer frameworks, compare them, and learn how to code over these frameworks. In the last slides, we have placed the sources that we used to make this presentation. Thank you.